In this video, we're going to take a look at a chi-square test for independence and some of the different things that we'll need to do at the beginning of our problem to set up, for example, our null and alternative hypotheses, find degrees of freedom, and so on and so forth. So, in this example, we've got students in grades 4 through 6 were asked whether good grades, popularity, or sports was most important to them. A two-way table separating students by grade and by choice of most important factor are shown below. Suppose that we want to perform a chi-square test for independence to determine if grade level is independent of most important factor. So, a few things here. First of all, whenever we're doing a chi-square test for independence, it will usually just say we want to perform a chi-square test for independence. So it tells me right there exactly what type of hypothesis test this is. Another way that we can tell is we will always have a two-way table if we are doing a chi-square test for independence. We will always see those. So we have our two-way table and we know that we're doing a chi-square test for independence. So first thing, of course, with any hypothesis test is to determine what is our null hypothesis and what is our alternative hypothesis. So we would like to know what is H naught and what is HA. So for these types of problems, the hypotheses are basically the same in every single scenario. When we talk about the null hypothesis first, we are going to begin by assuming that the two variables that we're discussing are independent, meaning that there is no relationship between them. We want to make sure that we talk about what those variables are. I would like to see you interpret what those variables are. So if I'm going to talk about these, I would say for H naught, we're talking about grade level and most important factor. So H naught we'll say is grade level and most important factor, are independent. And at that point, that's all I need to write. I can write that these two variables are independent. Then when I go to talk about my alternative hypothesis will just be that these two variables are dependent. So in this case, grade level and most important factor are dependent. Wonderful. So we have our null hypothesis, we have our alternative hypothesis. So we have those. The next thing that we're going to need to know is we need to know the degrees of freedom that we're going to be using for this two-way table. If you remember from the last video, we needed degrees of freedom to calculate our p-value, the area under our curve. So when we talk about degrees of freedom, we need to know two things. We need to know the number of rows times the number of columns. Do I have that right? Oh, no, I'm sorry. I misspoke. It's the number of rows minus 1. Minus 1 times number of columns minus 1. So when I go up and look at my two-way table, my number of rows, those are my horizontal rows. Now we need to be very careful here because the number of rows is not going to include the total row. So when I look at this, I've got a row for 4th grade, I've got a row for 5th grade, and then I've got a row for 6th grade. I'm not going to count that total row down at the bottom. So I have 4th and 5th and 6th, that's 3 total rows. So I have 3 total rows minus 1 times, I'm going to do the same thing for columns. My columns are vertical, so let's erase. So I have 3 different choices. We have whether grades are most important to them, popularity is most important to them, or sports or athletic ability. Again, I'm not counting that total column over there on the right. I'm just concerned with the total number of different outcomes or variables that are listed right here. So in this case, grades, popularity, sports, I once again have 3. So we're going to have 3 columns minus 1. So 3 minus 1 is 2, times 3 minus 1 is also 2. 2 times 2 gives me 4. This represents my degrees of freedom, and this is what I would need if I was going to go in my next step and find my p-value once I have my test statistic to go along with this. So I have my null and alternative hypothesis. I have my degrees of freedom. The other thing that I'm going to ask you to do in these types of problems by hand is to talk about the expected count. So when we talk about the expected count of our particular cell, we need to know the row total. The row total times the column total. Column total. And then we need to divide that by the overall total, or the table total. So this is where we are going to be talking about those row and column totals, and they are going to come in handy here. So we are looking at the 4th graders that chose sports as their most important factor. So I'm going to go up here. We said 4th graders that chose sports. So we are looking at the 4th graders right here that chose sports. So for the row total, I'm looking at the total number of 4th graders, which would be 119. So I'm going to have for this 119 times the column total. If I go back and look up here, my column total was 90. That was the total number of folks that said that sports was their most important factor. So 119 times 90. Divided by my table total. This is just the total number of responses that I have in my survey. So in this case, divided by 478. So divided by 478. And I'm just going to go ahead and do a little bit of multiplication and division here. So 119, 119 times 90 divided by 478. I ended up with 22. I'm going to round to 2 decimal places, 41. So this represents the expected count. This is the amount that we would expect to see if this null hypothesis is true. If my 2 variables are in fact independent, I would expect to see 22.41 4th graders that said sports were their most important factor. Now, obviously, I can't have 0.41 of a person. That wouldn't make any sense. So if you wanted to round that either up or down to the nearest whole number, I think that would be fine. Obviously, for any homework problems, make sure that you read carefully. I do believe that they're going to ask for decimals, so just make sure you read carefully to know how many decimal places to round to. I'm going to leave it as 2 decimal places, 22.41. I'll do the same thing then in number 4. We are looking for, in this case, the number of 5th graders that chose grades as their most important factor. So 5th graders that chose grades. Let's go ahead and erase. So let's look at our 5th grader row right here that chose grades. We're looking at this row and this column. So my row total in this case, the total number of 5th graders, 176. So I would take 176 times my column total. My column total, the total number that shows grades as their most important factor, is 247. So times 247. Again, divided by my table total, the total number of responses in my survey was 478. So divided by 478, I'm going to take 176 times 247 and then divide by 478, and I end up with 90.95 individuals I would expect to see there if the null hypothesis were true. Now, in these types of problems, we are going to be leaning heavily on our graphing calculator to find our p-value and our test statistic, but there are certain aspects I am going to expect you to do by hand, in particular these ones that I've talked about here. You should be able to list your null and alternative hypothesis, tell me what your degrees of freedom are, and then I'll usually ask you to find 1 or 2 expected counts for a given 2-way table. Those are skills that you're going to need to know for quizzes and tests going forward.